Hi dear students, this is the third part of the fifth module of the subject ME 206 Fluid Machinery, and in the second part we have derived an expression for work done for the reciprocating air compressor in the case of isothermal compression. Now in this first we will derive an expression for the polytropic compression. Expression for the work done by the reciprocating air compressor if the compression follows the polytropic compression, that is PV raised to N is equal to constant, where N is the polytropic index. So from the earlier presentation we have seen that the work done per cycle will be equal to area under this curve plus area under this curve minus area under this curve. We have seen that area under this curve is, that is B234 is P2V2, and area under A41CA, that is P1V1. So the final equation becomes area P2V2 plus area under this curve, that is area under BC12B minus area under this one, that is P1V1. So this is the final equation, P2V2 plus area BC12B minus P1V1. So P2V2 and P1V1 remains as such, but area under BC12B depends on the type of the compression. We have derived one equation for the isothermal compression. Once it becomes polytropic compression, the area under this curve will be different. So we will be deriving the expression for area under this curve and substitute in this equation. That is what we are going to do. Okay. So in the case of polytropic compression, as I have already told, the general equation to follow is PV raised to N is equal to constant. So area under the curve BC12B is integral V1 to V2 PdV, same as in the earlier case. But here PV raised to N is equal to constant, therefore P is equal to C by V raised to N. In the earlier case also we did the same thing. We have made an equation relation connecting P and V. So P is here, it is P is equal to C by V raised to N. Now I will substitute this equation instead of P. So area under the curve BC12B becomes integral C into integral of V1 to V2 C by V raised to N. Sorry, actually this C is not there, it is a mistake. Integral V1 to V2, instead of P I am substituting C by V raised to N into dV. Now C is a constant, therefore can be taken outside the integral, that is what is done here. So this term becomes C into integral V1 to V2 1 by V raised to N dV. So that is now integrating, actually 1 by V raised to N is V raised to minus N. So total term becomes C into integral V1 to V2 V raised to minus N dV. As we know, integral x raised to N is equal to x raised to N plus 1 by N plus 1. So integral of V raised to minus N becomes V raised to minus N plus 1 divided by minus N plus 1, and the limits are V2 to V1. Here we have changed the limit. You can see V2 to V1. The reason is V2 is less and V1 is higher. I think it is better to write here itself. You can change the limit from V2 to V1. That will be the better option. Anyway, V2 to V1. So this becomes C is constant, it is outside. Now substituting the first limit V1, this becomes, instead of V1 raised to minus N plus 1 minus, next term is V2 raised to minus N plus 1 all divided by minus N plus 1. This is constant, so minus N plus 1. But C is equal to, either we can, instead of C we can substitute either P1 V1 raised to N or P2 V2 raised to N. Both are okay. Now I am taking this C into the bracket, that is C is multiplied by first term in C into V1 raised to minus N plus 1. Here it becomes C into V2 raised to minus N plus 1 all divided by minus N plus 1. So instead of first C along with V1 I will substitute P1 V1 raised to N, and C value along with this term, that is along with V2 term, I will substitute instead of C P2 V2 raised to N. So the first term becomes, actually it is C into V1 raised to minus N plus 1. So instead of C I am substituting P1 V1 raised to N into V1 raised to minus N plus 1, and along with the second term, instead of C I am substituting P2 V2 raised to N into V2 raised to minus N plus 1 all divided by minus N plus 1, that is this minus N plus 1. Now you can see P1 you keep it here. The second term is v1 raised to n, next term is v1 raised to minus n plus 1. X raised to m plus x raised to n is equal to x raised to m plus n. So it becomes p1 into v1 raised to n plus minus n plus 1. N minus n will cancel, so only term remaining is v1 raised to 1, that is v1. So this term becomes p1 v1. Similarly, this term becomes p2 into v2 raised to n, v2 raised to minus n plus 1. That means v2 raised to n plus minus n plus 1, so v2 raised to 1. So this term becomes p2 v2. So the entire term is p1 v1 minus p2 v2 divided by minus n plus 1. So this can be that negative sign in the denominator I am taking to the numerator. So the value of numerator is reversed, that is p2 v2 minus p1 v1 divided by n minus 1. Therefore work done per cycle is p2 v2 plus area under this curve, that is p2 v2 minus p1 v1 by n minus 1 minus p1 v1. This was the general equation. So I have substituted area work done, instead of work done area under this curve I have substituted this value, that's all. So final equation become p2 v2 plus p2 v2 minus p1 by n minus 1 minus p1 v1. Now I will make the denominator common, that means n minus 1 is to be multiplied with this p2 v2 and p1 v1. So the term becomes work done per cycle is equal to n minus 1 into p2 v2 plus p2 v2 minus p1 v1, that is the middle term, minus n minus 1 into p1 v1 all divided by n minus 1. So you can see here n minus 1 into p2 v2 plus p2 v2. So this is n into p2 v2 minus 1 into p2 v2 plus p2 v2, minus p2 v2 and plus p2 v2 cancel. So n into p2 v2 will remain n by n minus 1 p2 v2. So n by, okay, anyway n into p2 v2. Similarly here it is minus p1 v1 is there, here minus n into p1 v1 minus 1 into p, minus of minus plus 1 into p1 v1. So this term and this term will cancel. So the remaining term is p1 v1 n into p1 v1. So the total term is n by n minus 1 p2 v2 minus p1 v1. You just write it in a paper and simplify it, then only you will get the exact idea. Finally you will get n by n minus 1 p2 v2 minus p1 v1. So this is the equation for work done per cycle, and this can be written as n by n minus 1. I am taking this p1 v1 outside, so n by n minus 1 p1 v1 into p2 v2 by p1 v1 minus 1. So for the polytropic process we have p1 v1 raised to n is equal to p2 v2 raised to n. From this equation you will get v2 by v1 raised to n is equal to p1 by p2. Therefore v2 by v1 will be equal to p1 by p2 all raised to 1 by n. And I am taking the reciprocal of this term within the bracket, that means 1 minus negative is added to the power. So this p1 by p2 raised to 1 by n will be equal to p2 by p1 raised to minus 1 by n. Usually if the term within the bracket is reversed, then one negative sign is added with the power, that's all. So p1 by p2 raised to 1 by n is equal to p2 by p1 raised to minus 1 by n. So work done per cycle becomes n by n minus 1 p1 v1, this is here, p2 by p1, this term is here, but instead of v2 by v1 I am substituting this one, p2 by p1 raised to minus 1 by n. Why I am taking this p2 by p1 is, here I am having p2 by p1 term, so if it is in the same fashion p2 by p1, then it is easy to simplify. So that's why I have reversed this side, okay. So the final work done per cycle becomes n by n minus 1 p1 v1 into p2 by p1 into p2 by p1 raised to minus 1 by n minus 1. So this is x raised to m into x raised to n. As I told, it is x raised to m plus n. So p2 by p1 raised to 1 plus minus 1 by n. So totally it is n minus 1 by n. So the final term is n by n minus 1 p1 v1 p2 by p1 all raised to n minus 1 by n. Actually, or it is all raised to n minus 1 by n. There is no option to substitute a bracket. It is very difficult to type the equation. That's why it is missing there. N by n minus 1 p1 v1 p2 by p1 all raised to n minus 1 minus 1. That p2 by p1 all raised to n minus 1 minus 1 is within the bracket, and to that term we have to multiply p1 v1 into n by n minus 1. So this is the work done equation for work done per cycle in terms of pressure ratio P2 by P1. Now we have to find the expression for work done in terms of temperature. For that we will use the same ideal gas equation we have from the ideal gas equation. PV is equal to MRT. So instead of P1 V1 I am substituting MRT1, that's all. So the work done per cycle will becomes N by N minus 1 MRT1 into P2 by P1 all raised to N minus 1 by N minus 1. So this is the equation for work done per cycle in terms of the temperature. Now work done per cycle in terms of temperature ratio we will obtain as, here it is in terms of pressure ratio. Instead of this pressure ratio, if you want to calculate the work done per cycle in terms of temperature ratio, we have the general equation P1 V1 by T1 equal to P2 V2 by T2. Therefore T2 by T1 by T1 equal to P2 V2 divided by P1 V1, P2 V2 divided by P1 V1. But for a polytropic process, we have already seen that V2 by V1 is equal to P2 by P1 raised to minus 1 by N. Here we have proved it. Just here we have proved it. So that can be used here. So T2 by T1 becomes V2 by V1 equal to P2 by P1 raised to minus 1 by N. So here I will substitute instead of V2 by V1. Instead of P2 by P1, I will substitute P2 by P1 raised to minus 1 by N. Here already one P2 by P1 is there. So N minus 1 by N will be the final term. So T2 by T1 equal to P2 by P1 raised to N minus 1 by N. You see this term is actually P2 by P1 raised to N minus 1 by N. So instead of this term I can substitute T2 by T1. So the work done per cycle in terms of temperature ratio is given as W is equal to N by N minus 1 MR T1 into T2 by T1 minus 1. That is the final expression for work done in terms of temperature ratio in the case of the polytropic compression. And one more thing I want to specify is, in each case I have mentioned in the earlier presentation and this presentation, we are deriving equation to find the work done per cycle only. But actually if you want to calculate the power and all, we have to multiply work done per cycle into number of cycle per second. If n is the speed of the reciprocating compressor, n is the RPM, number of revolution per minute, n by 60 will be the number of revolution per second. During one revolution, if it is single acting, during one revolution, one cycle will be completed. So if you multiply work done per cycle into n by 60, then you will get the power or work done per second. Actually this is work done per cycle. If you want to calculate the work done per second, just multiply this entire term with n by 60. That's how we will calculate the work done per second or power. Work done per second, if you calculate in terms of kilowatt, then you will, it is considered as the power. Usually power is expressed in kilowatt. That's all.